Hello everyone. Today we will discuss about the Legendry transformation. So let us see what is Legendry transformation and what is the application of it in the thermodynamics. So if you would like to draw a line, so what information is required? Suppose I have xy axis and I would like to draw a line. So I require the 2 points, that is x1 y1 and x2 y2. Let's say here, so I can draw a line with the help of this. The same line I can draw if I know the value of dy by dx, and that is called slope m and the intersection point C. So I can draw this line with the use of y is equal to mx plus c with the known values of x1 y1 and x2 y2, or with the known values of m and c. So here no information I am losing because I am representing the same thing, only the way of representation is changed. And this equation, this line of equation is given by y is equal to mx plus c, where y is dependent variable and x is independent variable and m and c are the constant. If I rearrange this equation, so I can write c is equal to y minus mx. So I am representing the same line of equation in another way. So my notification or my calling is different, but I am not losing any information. So what happening here is, now I have replaced my variable y to the x and another y to the c and x to the m. So with the known value of m and c, I can draw the line, or with the known value of x and y, I can draw the same line. This is called the Legendry transformation. So here I will change m is nothing but the dy by dx. Let's see one example for the enthalpy formation, and we will clear that how it is functioning. So for this, we know that the internal energy E U is a function of S, V and N, where S is entropy, V is volume, U is internal energy, N is the number of components. So I will replace this, I would like to replace this variable volume with their corresponding variable P, or thermodynamic property P. And for this, I will replace this C with the another notation, that is H. So we can write H is now in a function of minus P. So I am replacing what? In place of Y, my Y is U and X is what? V. I would like to replace M, and M is nothing but the dy by dx. So m is nothing but the dy by dx. It means that it is dou u by dou v. So dou u by dou v, where s and n are constant. This I can replace with another term minus p. How this minus p is come? We know the equation du is equal to, this is for x axis, this is for y axis. So du is equal to TdS minus PdV. Okay. du is equal to TdS minus PdV. How this comes? This is outcomes of the combination of first, second and third law of thermodynamics. So here I will divide V in a both side, keeping entropy constant. So this term will goes to 0 because entropy is constant, and here dou V by dou V, this goes to 1. So what will be remaining? It is minus P. So we can see here minus P we can replace with the M. Now coming back to our Legendry transformation, transformation. So y is equal to mx plus c, and I am changing c is equal to y minus mx, and c is nothing but the h, and y is u, m is minus p, and x is v. This I can write u plus pv, and we all know that the enthalpy is a summation of internal energy and multiplication of pressure and volume. So here we can see h is a function of uh, h is a function of u plus pv, or if I will put this, or I will differentiate this with respect to I will differentiate both sides. So I can write dh is equal to du plus pdv plus vdp. I could replace here. So this term I can write dh is equal to du plus pdv plus vdp. Now du is equal to, earlier we know that du is equal to tds minus pdv. So let's write here dh is equal to tds minus pdv plus vdp, and this plus pdv, and this both will be cancelled, and tds plus vdp, and hence we can write h is a function of sp, and if number of component is there, so sp and n. So finally we can say that we are changing the information from sv and n to sp and n with the new notation, and we call it enthalpy. So enthalpy is nothing but the function of sp and n. So here we are not losing any information. The only thing that we can see is this is the energy, but this energy is now represented in the form of enthalpy. So where pressure is the variable, we call that energy as enthalpy. Uh, Thank you for watching.